All right, here we have a proof here, which basically says that B is the midpoint of AC, which means here that these two segments have to be congruent if B is the midpoint. Similarly, we know that B is the midpoint of DE, which means these two segments have to be congruent. So let's take a look at how to solve this. They ultimately want me to get that BD is congruent to AB, these two little segments. I'm going to start off by writing my givens, and I write down the 2 points about the midpoint. From these 2 points, actually, if B is the midpoint of AC, again, I can say that AB is equal to BC. And I'm going to write that here, that actually AB is equal to BC. Similarly, I can write here that BD is equal to BE. And that comes from the definition of midpoint. Let's not leave this guy hanging. We know that AC is equal to DE because of the definition of congruence. Now I'm going to relate some things together, and so I want to find out some things. So I'm going to use my segment addition postulate. I'm going to say that AB plus BC is equal to this whole segment. Let's write that all out. And so I'm going to get here that AB plus BC is equal to AC. Similarly, I'm going to write that BD plus BE is equal to DE. Why is that important? Well, I know that AC and DE are the same. And so what I'm going to do here is I'm going to substitute, instead of writing DE here, I'm going to say that AB, oh, by the way, I can do this because of the segment addition postulate. And here, I can get that AB plus BC, let's see here, is equal to DE. And I can do that because I'm substituting instead of AC for this segment. So that's a substitution property of equality. We're almost done here. Let's see, AB plus BC equals, so I know these are both equal to DE, which means I can substitute again and just say that AB plus BC is equal to BD plus BE. What I'm doing here is I'm just setting these two equal to each other because they're both equal to the same thing. That's again another substitution property of equality. Last but not least, I know I ultimately need to get to BD, so I got BD here and I got AB here. It would be nice if these two I could get rid of. And I look back and I say, oh, AB and BC are the same. In other words, I can substitute and I can get here 2AB, because that will be just AB plus AB. That's going to equal, well, let's see, BD is also equal to BE. So in other words, I can get rid of B here and get 2BD. This is, again, what I'm doing here is another substitution property of equality. They ultimately wanted me to solve for this. So what I'm going to do right now is I'm going to actually flip these two. Okay? And I'm going to get here that 2BD is equal to 2AB. And that's because of a symmetric property of equality. And last but not least, I'm going to divide everything by 2, in which case I'm going to get that BD is equal to AB because of a division property of equality. And last but not least, I'm going to write that BD is congruent now to AB because of a definition of congruence. Long, long proof, but that's how we do that one there.